Okay, today we're going to go over the CC, the CC2, 2.2.1 review and preview. Sorry, technology problems today. We're going to go over problem 36 first. This is using a generic rectangle. We need to complete the following multiplication problems. We have 54 times 32 and 91 times 78. I do have to use a generic rectangle for this, so I start off by drawing my rectangle. Remember, I'm breaking apart my number by place value, so I have tens and ones, so 50 plus 4. And I draw this so my tens place value has a larger, so that this area right here is larger than the 4 because it's the tens place value. So 50 plus 4 and then 30 plus 2. And then I multiply, I find the area of each rectangle inside. So 3 times 5 is 15. Because it's 30 times 50, I have to put those 2 zeros in. 30 times 4, well, 3 times 4 is 12. And then because I'm multiplying by 30, it's 120. 2 times 50 is 100. And 2 times 4 is 8. I then add all these products together to get my final product. So I know what 54 times 32 is. So I have 1,500 plus 120 plus 100 plus 8. Start over here. 0 plus 8 is 8. 2 plus 0 is 2. 5 plus 2 is 7. And 1 plus nothing is 1. So the answer is 1,728. For part B, I'm going to do the same thing, except for now it's 91 times 78. So I have 90 plus 1 times 70 plus 8. 9 times 7 is 63. And then because it's 70 and 90, I have the 2 zeros. 90 times 8 is 70. 8 times 9 is 72. And then because it's 90, it's 720. 70 times 1 is 70. 8 times 1 is 8. I add up my products. So I have 6,300 plus 720 plus 70 plus 8. Start here. 0 plus 8 is 8. 7 plus 2 is 9. 7 plus 3 is 10. 6 plus 1 is 7. So 91 times 78 is 7,098. Okay, moving on to the next problem. I'm going to try to zoom in here a little bit. So below are some new distances with given lengths to help Cecil cross the tightrope. Find at least 2 ways to get Cecil across. Write your solutions as numerical expressions. Now remember, yours don't have to match mine, okay? Because there are lots of different ways to do this, as we found out in class today. So for part A, I have to go 6 feet, okay? I can only use 1, 3, and 4 to get there. So I'm going to start off simple. I can say, well, 3 plus 3, that's 6. I get a little bit more complicated and I can say, well, what if I used 3 plus 4, which is 7. So then I have to go backwards 1. Okay. Those are just 2 examples of something that I could write. For part B, I can go 8 feet. I can only use 2, 5, or 7 to get there. So I could do, let's see, 5 plus 7, which is 12. So then I need to subtract 4. So minus 2, which would work. I could go pretty simple and go 2 plus 2 plus 2 plus 2. I could get really complicated and say, well, 7 plus 7 is 14, plus 2 is 16, minus 5 is 11, minus 2 is 9, plus 5 is 14, minus 2 is 12, minus 2 is 10, and minus 2 is 8. Okay, again, these are just some of the things that you could use. Okay. Problem 38, we are simplifying each of the following expressions in order to find the length of the tightrope. I'm going to zoom in here. My first one, I have 5 plus 2, which is 7, plus 8. 7 plus 8 is 15. And it is feet because we're working with the tightrope problem still. Okay. 4 plus 9 is 13, plus 3 is 16 feet. Okay, 7 plus 3 is 10, plus 2 plus negative 4. I always rewrite it. I do one step and then rewrite the rest. So 10 plus 2 is 12, plus negative 4. 12 minus 4 is 8. This tightrope is 8 feet. Part D, 8 plus 6, 14, plus 2, plus negative 5. 14 plus 2 is 16, plus negative 5 is 11 feet. Okay, problem 39. Label the missing numbers on each number line. So there's a couple ways I can do this. I'm going to go through the way that I do it. If you have a different way to do it, feel free. So what I do first is I say, okay, what do I know about the number line? I know that 50 is the highest value and 20 is around the middle. But I also look at here. So between 20 and 0, there's 2 spots. Okay, two equal spots. So what I'm going to do then is 20 divided by 2, which is 10. So each one is growing by 10. And then I can fill it in to see if I'm correct. Okay, so I can do the same thing for the next one. So I have 32 and 4/10, and I can go, okay, there's 1, 2, 3, 4. So I'm going to take 32 and 4/10 and divide it by 4. 4 goes into 32 8 times. 4 goes into 4 1 time. So every section is 8 and 1/10. Well, 8 and 1/10 plus 8 and 1/10 is 16 and 2/10. Plus 8 and 1/10 is 24 and 3/10. Plus 8 and 1/10 is 32 and 4/10. Plus 8 and 1/10 is 40. Oh, I have to undo that because I'm touching the iPad while I'm drawing. It is 40 and 5/10. Okay, moving to the next one, 8 and 8/10. Again, I'm going to count how many spaces. So I have 1, 2, 3, 4. So 8 and 8/10 divided by 4. 4 goes into 8 2 times. And 2 times into 8 again. Bring up my decimals. So every space is 2 and 2/10. Well, 2 2/10 plus 2 2/10 is 4 4/10. Then 6 6/10, and then 8 8/10. But 8 8/10 plus 2 2/10. 8 plus 2 is 10. 8 plus 2 again is 10, plus 1 is 11. Bring down my decimal. It is 11. Okay, this last one, my 10 needs to be divided by 1, 2, 3 spaces. What we're going to get is 3 and 3 repeating. If I add that to itself, then I'm going to get 6 and 6 repeating. Then 10. Then it's going to go up by 3, so 13 and 3 repeating. And 16 and 6 repeating. Okay, moving to the back. Problem number 40. One of the topics you're going to be reviewing, which we have done in 6th grade math, we're going to keep looking at this. We're going to look at this graph on the right. And the graph shows positive and negative values on both axes, and it divides the flat surface into 4 parts, which are called quadrants. The whole graph is a 4-quadrant graph. Okay. So the coordinates in the x and y values for point A are -3, 5. We need to explain how these numbers tell you the position of point A using the graph. Well, -3 is going to tell us that we have to go 1, 2, 3 to the left because it's a -3. So we always start at 0, 0. Okay. -3 says to go 3 to the left. The 5 says, well, instead of going down 5, you have to go up 5 because it's a positive number. 5 tells us to go up 5 spaces. Okay, part B, name the coordinates for points B and C. So I have B and C. Remember, coordinates are written in parentheses. I'm going to use a line here to kind of help. So B is at about -5, -5. And the reason I'm drawing the lines is because I don't have a grid written down. So I'm actually going to erase what I just wrote. Normally I wouldn't count like that. Okay, I would use a pencil line and erase it. So it's -5, -5. Because I went to the left 5 and down 5. Point C, I went over 4 to the right, which means it's a positive number. And I still went down, but I went down 2 spaces instead. So, our next one. If Samantha moved point A 9 units down and 6 units to the right, at what point would she end up? So point A is at -3, 5. Now, -3 tells me if I'm going left or right. So I'm going to look at this 6. And I'm going to the right, which means I'm adding it. So -3 plus 6 is +3. Okay, that's my x value. Okay, so it would be at 3. And then this 5. So I have 5, and it says I'm going 9 units down, which means that I'm subtracting 9. 5 minus 9, -4. So my y value is -4. So that would be the new location of point A if it were to move. Okay, last problem is number 41. Gracie loves to talk on the phone, but her parents are trying to limit the amount of time she talks. They decided to keep a record of the number of minutes that she spends on the phone each day. Here's the data for the past 9 days. Okay, part A says to find the mean and median for the information. So I'm going to write down mean and median. First thing I'm going to do is rewrite the numbers from least to greatest. So I have, there's 3 zeros. And then 10, 15, 20, 30, 60, and 120. Okay, I need to find the median. So 1, 2, 3, 4. 1, 2, 3, 4. My median is 15. When I add all these together, I get 255. I have 9 numbers here, so I divide it by the number of numbers that I added together. 255 divided by 9 is 28. And it's 3 repeated. Okay. So now I know the mean and median, and they're similar, but the mean got a lot larger. Okay, it got more than 10 large. It increased by more than 10. Okay. So part B says, well, which of the 2 measures is going to give Gracie's parents the most accurate information about her phone use? Why do you think so? So the first thing we have to figure out are there any outliers, or is our data pretty symmetrical? Okay, so 0, 0, 10, 15, 20, 30, 60. And if we look here, from 60 to 120, we doubled our number. Okay, now it's significantly higher because I increased it by 60. This one here, we could argue it is doubled, but 60 is a lot closer to the rest of my data than 120 is. Okay, so there is an outlier, which means the measure that's going to be more accurate is the median. Okay, because the data is not symmetrical, which means the mean is affected more by the outlier of 120. As always, if you have any questions, please feel free to come